This is a short video to show the corrections for the probability test yourself questions on page 502. So starting with question 2a, Tony has thrown a dice 100 times and we've got to find an estimate for the probability that he'll get a 6. So using the data given, there are 36 out of 100, so that's 3/10. Part B. Work out an estimate for the number of times the coins will land on a head. So this is slightly different now. This is Emma throwing a coin. And the number of times she throws it is 250. The probability of getting a head is 0.7. So you want 250 times 0.7. Give you 175 heads. So the next question to correct was question 4, part A1. And you had to find the relative frequency of the spinner landing on 1. So whenever you see relative frequency, I always suggest you think of probability. So think of the probability here of getting a 1. To do that, you count up the number of 1s in the experiment, which is 7. And you put it over the total number of spins, which is 20 in this case. So the answer is 7/20. So this is part 2, I wrote B in error. You have to explain why if Steve also spins it 20 times, the results won't be the same. Well, it's a different experiment, so you wouldn't expect the same results. Now this should be part B. And you have to find how many times you would expect a result of 3 if you spin the spinner 1,000 times. So start by finding the relative frequency of getting a 3. So remember what I said before, where you've got relative frequency, think of finding the probability of getting a 3. So the number of 3s in the experiment was 5, and the total number of spins was 20. Then once you've got that relative frequency, you multiply it by the number of spins, which in this case is 1,000. So it's 5/20 times 1,000, the answer being 250. So the next question we're going to look at is question 5, I believe. So this time you've got a dice, it's thrown 300 times, and the probability of a 2 is 0.12. You have to estimate the number of 2s in 300 throws. So that is the probability of a 2 times 300, and the probability of a 2 is 0.12 from the question. So the answer is 36. Part B, work out the probability that on the next throw it will land on either a 2 or 4. So that's the probability of 5 is probability of 2 plus, because it's or, the probability of 5. The probability of 2 we already had was 0.12, and now we're told probability of 5 is 0.35. Add those together to get 0.47. And question 6, you've got some data about the probability of another spinner with letters A, B, C or D, and you want the probability of a D. So that's 1 minus the probability of A minus the probability of B minus the probability of C. The final answer is 0.26. So part B, you have to work out an estimate for the number of times the spinner will land on A given 300 spins. So that's similar to an earlier question, question B, 4B. So it's 300 spins times the probability of A. So that's 300 times 0.15. That was given in the question. Final answer 45 A's. Question 7 is a probability tree question. In which Rebecca is playing snooker and the probability she wins is P. So just drawing out what was in the question. The first branch is game 1, second branch is game 2. And you're given that a probability of a win is P in both games. So the probability she loses, I'm going to write that in green, is 1 minus P. So part B, you have to work out the probability that she wins on both games. So that's going to be my red line that I'm going to draw in a minute. The red path there. So it's P times P, which is P squared. Part C, you have to find the probability that she wins exactly once. So there's two paths that could possibly be. And we'll draw those in different colours. The first path we're going to draw in blue. So that's a win and a lose. That's P times 1 minus P. Well, the other path in purple is a lose then a win. So that's 1 minus P times P. If we just rearrange to make it a little bit clearer what we're doing, that gives us 2 lots of P in brackets 1 minus P. That's the final answer. So question 10. You've got another spinner and there's 8 possible values. 1, 4, 1, 2, 3, 1, 4, 2. The probability of any of those is 1/8. You've got to work out the probability of getting exactly 1, 4. So the probability of exactly 1, 4 is the probability of a 4 then not a 4, or the probability of not a 4 then a 4. So the probability of a 4 is 2/8. The probability of not a 4, there are 6 different possible options, 6/8. And then similarly, probability of not a 4 is 6/8 times probability of a 4 is 2/8. So that's 3/16 plus 3/16. Simplifying gives us 3/8. Then moving on to a slightly different exercise, which is on page 527, exercise 3. Which is really on sequences and a bit of algebra. You've got this set of equalities, which is given in the question. So bear with me while I write those down. So all the numbers in black were given. Now we've got something we don't know, which is the green A and the red B. So in part A you have to find A by looking at the pattern. So if we look at the pattern from the numbers above, 1 to 3 to 5 to 7 to A, Look at the steps each time. You've got 1 to 3, 3 to 5, 5 to 7, 7 to A. So we've got plus 2, plus 2, plus 2, plus 2. So 7 plus 2 gives you 9. A bit trickier with the red B, because those numbers are not a linear sequence. They don't just go in even steps. If you look at the 2 to the 8, the 18 to 32, let's write those down separately. 2 to 8 is 6, 8 to 18 is 10, 14, and then we don't know, but we look at the second difference is 4. So if we add 4 to the 14, that would have been 18, add that to the 32 will give you your B. The answer is 50. So for part C, you have to give the next line in the pattern. So that should have been 7 times 11 at the beginning there. Apologies for that. Minus 6. The 72 comes from my yellow values. I'm adding 4 to the 18, and the 22 to 50 gives me the 72. Yeah, so just to repeat, that 6 at the beginning of that line should be a 7. Okay, thank you.